Simplifying algebraic expressions. A mathematical expression that contains a variable is called an algebraic expression. When there are multiple terms, it can be called a polynomial. Let's get into operations with polynomials. To add or subtract polynomials, combine like terms. Let's take a look at an example. 6x squared plus 2x minus 4 minus 2x squared plus 3. So we'll look for the like terms, but the first step is distributing the negative sign to the two terms contained in the second set of parentheses. That gives us a negative 2x squared and a negative 3. So all we have to do is combine like terms. The x squared terms, the x term, and the terms without variables. So now we're looking at 6x squared minus 2x squared plus 2x plus negative 4 minus 3. That gets us 4x squared plus 2x minus 7. To multiply binomials, use the strategy FOIL. FOIL stands for first, outer, inner, last. This describes the order in which terms and polynomials should be multiplied. Let's look at an example to see FOIL in action. X plus 6 times x plus 2. So, using FOIL, we'll do the first terms, x times x. That gets us x squared. Now the outer terms, x times 2. That gets us 2x. Now the inner terms, 6 times x, that's 6x. Finally, 6 times 2. So that leaves us with these four terms, x squared, 2x, 6x, and 12. Now we'll combine the two like terms, 2x and 6x, to get 8x. And our final term looks like this, x squared plus 8x plus 12. FOIL works exclusively with binomials. If you are multiplying a polynomial with more than two terms, you must multiply each term in the first polynomial with each term in the second polynomial. Let's look at an example. 2x squared plus 7x plus 6 times x plus 3. So we'll distribute 2x squared, 7x, and 6 to x plus 3 individually. 2x squared times x is 2x cubed. 2x squared times 3 is 6x squared. 7x times x is 7x squared. 7x times 3 is 21x. 6 times x is 6x, and 6 times 3 is 18. So now we have our terms 2x cubed plus 6x squared plus 7x squared plus 21x plus 6x plus 18. Now let's combine like terms, those being 6x squared and 7x squared, and 21x and 6x. So when we combine those two, we're left with our final term, 2x cubed plus 13x squared plus 27x plus 18. Now, what about division? When dividing algebraic expressions, the following formula is used. X plus y over z equals x over z plus y over z. While that may not look too helpful like that, it can simplify some more complex equations. For example, x squared plus y over x. You can rewrite the equation as x squared over x plus y over x. That simplifies to x plus y over x. When there's more than a single variable in the denominator, we usually factor the expressions and then cancel, instead of using the above formula. For example, x squared minus 2x plus 1 over x minus 1. You can factor the top equation to be x minus 1 times x minus 1, and it would simplify to x minus 1. Let's get to the practice problem. When 3x minus 4 squared is written in the form ax squared plus bx plus c, where a, b, and c are integers, what is a plus b plus c? The question is asking you to do is to expand 3x minus 4 squared to the form ax squared plus bx plus c. How do we do this? FOIL. Don't be thrown off by the fact that there's only one term in 3x minus 4 squared. The fact that the term is being squared means that there are in fact two terms. Two identical terms multiplied by each other. So that means we have 3x minus 4 times 3x minus 4. Now all we have to do is FOIL. F for first, 3x times 3x, O for outer, 3x times negative 4, I for inner, negative 4 times 3x, L for last, negative 4 times negative 4. So we have 9x squared minus 12x plus 16. We can combine both negative 12x's and get negative 24x. So now we have our term 9x squared minus 24x plus 16. Now we have the ax squared plus bx plus c form that the problem asks for. We're looking for the sum of a plus b plus c. Well, as you can see, A is 9, B is negative 24, and C is 16. You simply have to add these three integers together and you'll get negative 1. And that's our answer.